This is a subsequent class of the previous class, and in this class, we will understand what is TCP connection establishment. A connection is established between the two hosts before any data is transferred. When the term connection is established is used, this means that both the computers know about each other and have agreed on the exchange of data. For a connection to be established, the two end hosts must follow the three-way handshake process. You will see the SYN and ACK bits in the code bits field of TCP header which are used to perform the three-way handshake. For a connection to be established, the two end stations must synchronize on each other's TCP initial sequence numbers. The sequence number is the tracking order of the data, and it ensures that no data are lost in transmission. The initial sequence number is the starting number used when a TCP connection is established. Please always remember, TCP initial sequence numbers do not start with a number 0 or 1. There are several reasons for this, including segments that may still be in buffers and also security issues. The sequence number is the initial sequence number, is randomly chosen, and is used to begin tracking the flow of data from the client to the server. Let's understand the three-way handshake process. The three-way handshake is a process which happens before any data is being sent by the client. In the first step, a TCP client begins the three-way handshake by sending a synchronization packet with a control flag set to SYN. In the second step, once a server receives a synchronization packet from the client with a control flag SYN, the TCP server responds with a segment containing an acknowledgement packet with a control flag ACK. It is the response to the TCP synchronization packet sent by the client. Along with the acknowledgement, the server also sends an initial synchronization packet back to the client with control flag SYN. In this case, the server set two flags in the same packet, SYN and ACK. A flag set indicating that the acknowledgement number is significant. The value of the acknowledgement number field is +1 of the client's initial sequence number. This is called an expectational acknowledgement. Here again, a server has randomly chosen the sequence number and is used to begin tracking the flow of data. In the third step, the TCP client responds with a segment containing an acknowledgement with control flag ACK, that is the response to the TCP synchronization packet sent by the server. The value in the acknowledgement number field contains the very next number of the initial sequence number received from the server. Now the three-way handshake process is done, and the client can send application data encapsulated in the TCP segment. Let me explain this again in a simple way. Let's assume I have a PC and I am trying to access a website to download data. In the step 1, PC sends the initial packet to server. This packet has the control flag SYN enabled. Server receives the packet and notices the control flag SYN is enabled in the packet, which has a value of 1. With this indication, it knows that the PC is trying to establish a connection with the server. In the step 2, now the server sends a packet back to the PC with control flag SYN and ACK enabled. In the step 3, at last, the PC sends another packet to the server with the control flag ACK enabled. Once the three-way handshake is complete, the connection is established and the data transfer begins. Similar to connection establishment, there is one more process available to terminate the session. Let me explain. When the client has no more data to send in the stream, it sends a segment with the FIN flag set. The server sends an ACK to acknowledge the receipt of the FIN to terminate the session from client to server. The server sends a FIN to the client to terminate the server to client session. The client responds with an ACK to acknowledge the FIN from the server.